In this video, we will discuss how do we differentiate a quotient of two functions if these two functions are differentiable, right? Again, here we're starting from f and g here are differentiable functions, right? Which means the derivative exists, right? So I dot e f g here, f prime g prime exist, right? And before we do that, before we can get a new function which is called uh, f of x over g prime g of x, right? We want to differentiate this function, and clearly we need to assume that g prime of x is not zero, right? Now, before we do that, let's see one easy formula first, right? So this is same as let's try to look at the derivative of the reciprocal of this function, right? If you have a formula for 1 over g of x, then the first one here is nothing but f of x times 1 over g of x, then prime, you can apply the product rule, right? So this is same as f prime of x times 1 over g of x plus f of x times 1 over g of x prime, right? Then if you know the derivative of 1 over gx, you can plug in, right? So this is that's how do we use a product rule, right? Now, how do we get it, right? Again, here we don't have good way. We just go back to our formula. So this is same as h goes 0, 1 over g of x plus h minus 1 over g of x over h, right? And because g prime exists, we know that as h goes 0, g of x plus h minus g of x over h goes to g prime, right? So that's all we know. So this is equal to try to arrange it, follow the algebra rule, right? H goes 0, H goes 0. And okay, so common factor, which is g of x plus h times g of x and times h, right? Look at this is g of x minus g of x plus h. Okay, we know the limit of g of x plus h minus g of x over h, and we know that these two factors here as h goes 0 because g differentiable, so it's continuous, right? If you want to get the limit, all you want to do is a plug in 0, right? So this is equal to as h goes 0, negative, we switch order, 1 over g of x plus h times g of x. The second group is g of x plus h minus g of x. So this negative, pull out negative, change the orders, right? Now you can see that the second group here goes to g prime. Then the first group here goes to 1 over g square of x, right? Because g of x times g of x is g square of x. So this is negative g prime of x over g square of x, right? This is how do we develop the formula for the derivative of 1 over g of x. We just follow the algebra definition, right? Definition of derivatives. So this is equal to f prime of x over g of x, then plus f of x times negative g prime of x over g square of x, right? Take out the common factor, you get g square of x in the denominator. This is f prime of x times g of x and minus f of x times g prime of x, right? So this is our quotient rule and also the rule for the reciprocal of a given function, right? Let's write down easy, just a single formula here. So f over g prime is f prime times g minus f times g prime over g squared. 1 over g prime is negative g prime over g squared. So this is our quotient rule, and also actual rule allows us to differentiate a reciprocal of some given function here, right? Okay, now let's see a couple examples, right? Couple examples on how do we differentiate functions, right? So let's see example using all the rules we have, right? Examples. Let's try to differentiate its function. First function here is f of x equal to 1 plus x over 2 minus x. We want to find f prime of x, right? So clearly, this is a quotient of two functions. Numerator is 1 plus x. Denominator is 2 minus x, right? All the rules we have learned before quotient rule fails because it's impossible to write this as a sum or difference of power functions, right? So f prime of x equal to, follow our rule. This is our numerator. This is our denominator, right? Derivative of the numerator, which is 1 plus x prime times denominator 2 minus x, then minus 1 plus x numerator times 2 minus x prime, right? Over 2 minus x squared. Now we want to differentiate 1 plus x. You get 1, right? Because 1 prime is 0, x prime is 1. So you get 2 minus x minus 1 plus x. The derivative of 2 minus x is 0, negative 1, because derivative of 2 is 0. The derivative of negative x, which is negative 1 times x, using the constant multiple rule, this is negative 1, right? Over what? The same function, no derivative involved in the denominator, right? So this is the derivative of this function here. Okay. So let's see one more example, right? B here, our function f of t is 2 minus root t e to t and t plus e to t, right? We want to find f prime of t, right? Imagine numerator is a difference of two functions. Second term is a product of two terms, two factors. A denominator is t plus e to t, right? So f prime of t, as always, this is 2 minus root t e to t prime t plus e to t, and then minus 2 minus square root t e to t, then t plus e to t prime. So this is purely using quotient rule, right? T plus e to t square, right? So now we want to differentiate the smaller terms. The derivative of this, you have to use difference rule, and also in the second term, you have to use product, right? 2 prime is 0, we know that. So this is negative. The derivative of root t is 1 over 2 e to negative 1/2 t2, sorry. T to negative 1/2 t to negative 1/2 times e to t, then minus root t times e to t, because the derivative of e to t is still e to t, right? Then t plus e to t. then minus 2 times root t e to t, then times 1 plus e to t. Just the direct application of sum rule, right? Over t plus e to t square. So this is due to this big function here. You don't have to simplify this in a test or our final exam, right? This is good.